let's talk about our cosecant graph. Now remember, cosecant is the reciprocal of sine. So if we just go ahead and graph our sine graph and then think through the reciprocal of that graph, we will have our cosecant graph. So we can honestly start graphing cosecant. The easiest way to graph cosecant is to graph sine first. So if you remember, our sine graph would go starting at 0, and then at pi halves it goes up to 1, and then at pi it goes back down to 0, and then at 3 pi halves it goes down to -1, and then at 2 pi it's back up to 0, and it just keeps repeating from there, right? That's our sine graph. Now our cosecant graph will be the reciprocal of that. So just like we said with when tangent is smaller than 1, cotangent is bigger than 1, well, sine is always less than 1. So cosecant is always going to be bigger than 1. And where the numbers for sine are the smallest, like if you had 1, think of a really small number, 1 over 100. Let's say our ratio is 1 over 100. Then that would mean that cosecant is 100, because the reciprocal of 1 over 100 is 100, right? So that throws our point clear up here, heading toward an asymptote, because the reciprocal of 0 is undefined. So it helps to think about what those sine values are. So if the sine, so let's just think about our sine values really fast. So if sine is 0, then cosecant's going to be undefined. If sine is 1/2, then cosecant is going to be 2. If sine is square root of 2 over 2, which is 0.7, I think is what we calculated, it's going to be the reciprocal of 0.7, whatever that is. So I copied these off of a previous page. Let me just copy them on, see if they'll go where I want them to. Looks like I can move them to where I want them. Oh, dang, the whole thing didn't stay selected. Try that again. Okay, be careful. So I previously wrote these down. So reciprocal of 0 is undefined. Reciprocal of 1/2 is 2. Reciprocal of 0.7 is 1.4. Reciprocal of 0.86 is 1.2. So notice as the sine numbers get bigger, the cosecant numbers get smaller. But then when sine is 1, the reciprocal of 1 is 1. So that's the lowest that cosecant will go, is 1. Because after sine becomes 1, sine starts getting smaller again, which means cosecant starts getting bigger again. Hopefully this inverse relationship makes sense. So here's these lines I set aside. These are my asymptotes. So everywhere that sine has an x-intercept, cosecant's going to have an asymptote. So I'm placing my asymptotes at those key points for sine. Notice how I didn't actually sketch in the sine graph, because the key points are enough for us to figure out where cosecant's going to live. And we don't want the actual sine graph, we want the cosecant graph. We're just using the guideline points for the sine graph to help us with the cosecant graph. Because where sine is 1, cosecant is 1. And where sine is 0, cosecant is undefined. So I've got my asymptotes where it's 0, where sine is 0, so where cosecant is undefined. And now just realize that your maximum value for your sine is going to become a local minimum value for your cosecant. And then this minimum value for sine is going to be a local maximum value for the cosecant. So the cosecant ends up just reversing what that sine looks like. Drawing these curves is harder than it should be. Here it might look better on what I drew up last year, so we'll just kind of switch to that at this point. So I even did put the sine graph in there so you could see it. I just left it dotted. So the reciprocal of that sine graph are these branches of the cosecant graph. So that just keeps repeating forever. The easiest way to sketch cosecants is to sketch the sine first. Put your asymptotes where the zeros are. Put your minimums and maximums where those are. They just line up. And then flip them the other direction from where the sine graph curves. Right. So just like sine, the period for cosecant is going to be 2 pi. So I've got that written right here. Period 2 pi, because the period of sine is 2 pi, so the period of cosecant is also 2 pi. So far we've learned that tangent and cotangent have a period of pi, but sine and cosine, and therefore cosecant and secant, are all going to have that period of 2 pi. Okay, our domain is everything except where the asymptotes are, which is at integral values of pi. So at 0, pi, 2 pi, 3 pi, negative 2 pi, right, for any k value that's an integer. The range is kind of interesting because the range is going to go from negative infinity to -1. Oh, I guess I should go from bottom to top. That's how we usually do range. So let's look at this piece from going from negative infinity to where it stops. So negative infinity as the graph approaches those asymptotes, and then up to -1, where it does not exist between 0 and 1 because, or I mean -1 and 1, because that's where sine exists. And so cosecant is always the reciprocal of sine. It will never be those sine values. All right, so then our range starts up again after the gap at 1 and then going to positive infinity. And cosecant has no x-intercepts because it never touches the x-axis. It is never 0, just undefined. All right, any questions about cosecant at all? All right, so on to secant. So just like cosecant, secant is the reciprocal of cosine. So 1 over y equals cosine, right? So whatever values for cosine we have here, like the cosine of 0 is 1, the reciprocal of that, sorry, I was going to put those values up there. The reciprocal of that is 1. Or the cosine of pi 6 is square root of 3 over 2. And so the reciprocal of, which is like approximately 0.86, I think, and the reciprocal of that is like 1.4. And then this one would be square root of 2 over 2, so the reciprocal of that, which is about 0.7, is like 1 point. Maybe I've mixed up my intervals. Maybe this one was more like 1.7. Uh-oh. Now I can't remember. They should be the same numbers I had on my last chart. Okay, 1.4 was right. I just was not remembering. So this would be more like 1.2, the reciprocal of square root of 2 over 2. And then the cosine of pi over 3 is 1/2, so that reciprocal is 2. And then the cosine of pi halves is 0, so that's where it's undefined. So you can see anywhere that cosine would have that, I'll just sketch this in really fast. Anywhere that cosine goes through the x-axis, I didn't go up high enough, fast enough here, or vice versa. I'm not quite making my mark. Needs to go through here and then back up to there. There we go. That's approximately our cosine, right? So anywhere that cosine normally crosses the x-axis is an asymptote. So that's at pi halves, 3 pi halves, 5 pi halves, 7 pi halves. And anywhere that cosine has a maximum or a minimum, our secant is going to have a local minimum or a local maximum. So we end up with a graph that looks like this. You can see how I've got that cosine in between, and then the secant is going the opposite direction, approaching those asymptotes to infinity. So the domain is everything but values of pi halves, right? So pi halves plus k pi. The period again is 2 pi. The asymptotes are at those values of pi halves. And then the range is exactly the same as cosecant. So from negative infinity to -1, with a gap in between -1 and 1, and then continuing on from 1 to infinity. So there's our secant graph and its properties.